There we go. All right. So the title of the notes today is Solving Quadratic Equations by Factoring. So minimize all the camera, that might help. So a little lag time. Hopefully that will improve. All right. Solving quadratic equations by factoring. The good news about this module, well, what I think you will find as being good news, is that, bless you, there's not a lot of graphing in this module. I know y'all don't usually love the graphing stuff. Am I right or no? Yeah. Okay. Well, some will like it better, I guess some won't. All right, the lesson essential question, we're not going to write this down, I'm just going to say it out loud. What are the steps used to solve a quadratic equation by factoring? All right, so that is what we want to learn today. So example 1, we are going to use factoring to solve 5x squared plus 11x plus 2 equals 0. And I'm going to rewrite my problem down below so I have enough room on the right side to write the steps. Okay, so quadratic equations. You know you have a quadratic equation when your highest degree is 2. So remember, a degree is kind of like an exponent, but not exactly. A degree refers to the exponent of the variable, okay? So like my first term, 5x squared, we say that term has 2 degrees because x's exponent's 2. The middle term, positive 11x, that has 1 degree because x's exponent is a 1. The plus 2 does not have any variables, so we say it has 0 degrees, okay? 2 has an exponent of 1, but a degree and exponent is different. Since it does not have a variable, we say it has 0 degrees. So in standard form, you always go highest degree to lowest degree. And when I say how many degrees does this equation have, this function have, it's whatever your highest, the term with the highest number, that's what we say how many degrees we have. So we would say this has 2 degrees, okay? It's the highest degree. So anytime you have a equation with 2 degrees, that's called a quadratic equation, okay? So 5x squared is our quadratic term. 11x is our linear term because 1 degree is linear. And then 2 is our constant, okay? So the method that I'm going to show you today, there's, I don't know, 5 or 6 different methods of factoring. And probably every teacher that you've had that taught you this probably showed you a different method. Okay, there's lots of different methods. I used to show all the methods and then let you choose what you want. Well, that was really confusing. And so this method that I'm going to show you, I feel like I've had the most success with it. I feel like more students understand this way than any other method that I've done. All right. If you remember how to factor from a previous class and you're like, I don't like your way, it doesn't make sense, I like the way my other teacher did it. Okay, do it that way. I don't care. As long as you know how to do that way and you can do it correctly. Okay. So if you know how to factor already and you can do it correctly, then do it that way. Otherwise, give my way a shot. Okay. All right, so the first thing you want to do when you are solving a quadratic equation is you want to get it set equal to 0 and put it in standard form if it's not already. Is this one set equal to 0 and in standard form? Yeah, okay, sweet. We don't have to do that. But on this first one, we're writing down some steps. So let's write it down. Set equal to 0 and in standard form if not already. That's your first step. Set equal to 0. And in, I'm going to say SF. What does SF mean? Standard form. Set equal to 0 and in standard form if not already. So that step, we don't have to do that. It's already in standard form. It is already set equal to 0. SF, what does that mean? Standard form. You can write standard form if you want. The next thing I'm going to do is check for a greatest common factor. And if I have one, I'm going to factor it out. So factor out any greatest common factors, which from here on I'll refer to as GCF. Do I have a greatest common factor? Is there a number that will divide into 5, 11, and 2 evenly other than 1? No. 1 is the common factor, but it doesn't help to factor it out. So do we have x's in every term? No. So there's not a greatest common factor. Excellent. So the next thing I'm going to do is define A, B, and C. This is not your first time learning about quadratics, okay? But just as a reminder, the standard form of a quadratic is ax squared plus bx plus c equals 0. Sometimes it equals y, sometimes it equals f of x, but we're solving, so we're going to get it set equal to 0. So when I say define a, b, and c, a is the coefficient of your quadratic term, b is the coefficient of your linear term, and c is always the constant, okay? Sometimes you won't have a b or a c. Those would be 0. But you have to have an a, otherwise it's not a quadratic, okay? So what is a in this case? It's only the coefficient, 5. What is b? And what is c? Awesome. All right, so the next step, we're going to make a little T-chart. And the little T-chart helps us figure out our factors. Oh, I forgot to ask you. First of all, what do I mean when I say factors? If I said, what are the factors of 12, what would you tell me? 6 and 2, 1 and 12, 4 and 3. What did I multiply together to get 12, right? That's what factors are. So I'm trying to figure out what could I multiply together to get 5x squared plus 11x plus 2. That's my whole goal, okay? So this is the process I would use to try to figure that out, trying to figure out the factors. So on the left side of the T-chart, I want to find two numbers that multiply together to give me a times c. And on the right side, I want to find two numbers that add together to give me b. Well, first of all, what is a times c? 10. What? Well, just 5 times 2 was what? 10. So a times c is 10. And what is my value of b? 11. So I want to try to find two numbers that when I multiply them together, I get 10, and when I add them together, I get 11. So let's think about it. Factors of 10. Well, 5 times 2 is 10. But hold up. What's 5 plus 2? I need it to be 11. Just because it works on the left side does not mean it's going to work on the right side. So what was that you said, sir? Okay. 10 times 1 is 10, and 10 plus 1 is 11. Boom, we found it. Positive 10 and a positive 1 is what worked on both sides. Okay? Y'all down with that? Okay, so go back up to your problem. Make 2 sets of parentheses. Whatever variable that's being used is going to be the first term in each set of parentheses. So what variable are we using in this problem? X. So X is going to be the first term in each set. The second term in each set comes from the T-chart that we made. What were the two numbers that we multiplied together on the left side and added together on the right side? 10 and 1, and they were both positive, right? So put a plus 10 in one set and a plus 1 in the other. It does not matter which one gets the 10 and which one gets the 1. But some students make the mistake if they put the x's both in one set of parentheses and a 10 and a 1 on the other set, and that won't work out right. Okay? Well, this method of factoring is called the divide and slide method. Divide and slide. All right, well, why are you calling it the divide and slide? Because of this part right here. So once I get my parentheses, listen up, because this is where the confusion comes in. It's not difficult, but if you forget this step, the whole thing's wrong. Look at the A in your T chart. A was a 5, okay? I want to divide both of the numbers that I took out of the T chart by whatever A is. If it does not divide evenly, I'm going to slide, okay? So I took out a 10, I'm going to try to divide that by 5. I took that 1 I got from the T chart, I'm going to try to divide that by 5. If it divides evenly, divide. If it doesn't, you slide, okay? So 10/5, does that divide evenly? Yeah. So I will call that the divide. Does 1/5 divide evenly? No. So that side is going to be a slide. Sometimes you have 2 slides. I don't think I've ever seen 2 divides. Yeah, there can be 2 slides. I don't think I've ever seen 2 divides. Yeah. Here's the thing. If it's a slide and you can reduce it, you must reduce before you slide. If you don't, it won't be right. Usually that only happens when they're both slides, okay? I don't think I've ever seen it reducible when you have a divide and a slide. Yes. Well, if it's is it a 20 divided by 10, then it would be reduce it to 2. So if it divides evenly, you divide. Yeah, because 20 divided by 10 is 2. Okay. So let's write this down. So we have, you said 10 divides by 5 evenly. What is 10 divided by 5? So we'll replace that with x plus 2. The 1/5, 1 does not divide by 5 evenly. 5 divides by 1 evenly. 1 does not divide by 5 evenly. Can I reduce 1/5? No. So here's how you slide. It's really difficult. Not really. Oh, no decimals. We don't have decimals. We slide the 5 over in front of the x and bring down the plus 1. So instead of x plus 1/5, it will be 5x plus 1. I know, right? So difficult. That's the slide and divide method, people. That wasn't that difficult, was it? No. Don't be silly. Okay, so those are my factors. I'm telling you that x plus 2 times 5x plus 1 would give me 5x squared plus 11x plus 2. Do you believe me? Well, let's just multiply it out in our head. We won't write it out, okay? If I distribute and get rid of the parentheses, I should end up with what I started with. So let's do x times 5x is what? X times 5x is what? I'm distributing in my head. 5x squared. Notice my first term is 5x squared. X times positive 1 is 1x, and 2 times 5x is 10x. So 1x plus 10x is 11x. Isn't that my middle term? Yeah. And then 2 times 1 is 2. That's my last term. The 2 middle terms you would be. You want me to write it down? Are you confused? Okay. I'm just going to, this is just me showing you that they are the factors. So x plus 2 times 5x plus 1. So I'm going to distribute. X times 5x is 5x squared. X times 1 is 1x or just x. 2 times 5x is 10x. 2 times 1 is 2. Combining like terms, x and 10x are my only like terms, I would get 5x squared plus 11x plus 2. Isn't that what I started with? Yeah. So it's true. You can multiply those together to get 5x squared plus 11x plus 2. They are factors. Right on? Crouton? Okay. So the question said use factoring to solve. So sometimes we just are factoring things, right? And if I'm just asked to factor, then my factors are x plus 2 and 5x plus 1. But this said use factoring to solve. So we still have one more step. That step's easy. We've done the hardest part. That wasn't that difficult, was it? They really don't get much more difficult than that. The only thing is if we have a greatest common factor or if the numbers are giant, but this one isn't. Okay, so to solve, set each factor equal to 0 and solve for the variable. Everybody's heads need to be up off their desk, eyes open. I think I said how important this lesson is. Don't make me come tap on your shoulder. I'm making a video here, people. So I have two factors. X plus 2 is a factor. 5x plus 1 is a factor. Okay? So I'm going to set them equal to 0. So I'm going to set x plus 2 equal to 0. And I'm going to set 5x plus 1 equal to 0. So I'm going to get two solutions, right? Well, a quadratic always has two solutions because however many degrees your equation has tells you how many total solutions you can have. We're going to have two because a quadratic is two solutions. They might be two real solutions. They might be two imaginary solutions. You can't have one real and one imaginary, but we'll get to that later. Okay, so just solve both of those. You don't need me for that. Would it be easier for you if you scoot back one? Would it be easier to see? Up to you, but I know you have to lean around or over here as well, in front of Toby, whatever you want. Whatever's easiest. All right, so my answer is -2 is one of my solutions, and -1/5 is the other solution. Does anybody know what these solutions would tell me about my graph? No. No. Quadratics don't have a slope. Yeah. Any other guesses? What the solutions mean about a graph? What do you mean on -2? Where? Are you saying on the x-axis? Oh, okay, that's correct. These 2 points, and I would bring up Desmo so we could see it better, but I think because I'm recording, if I open that, it'll take forever to record or to open. So I put it on my graphing calculator. I entered the equation into my graphing calculator. You'll see it in probably 5 minutes there. Oh. So I entered 5x squared plus 11x plus 2. Okay. And then I push the graph button to see the graph of this equation. And I can see where it crosses the x-axis. So right at -2, that looks like a -2, right? The left side looks like a -2. And the right side is somewhere between 0 and -1. And -1/5 is what, -0.2? And I can trace this or calculate to find exactly if that's exactly where it crosses. That's going to take more time than we have, and we will do that down the road. But just as a quick check, it looks like it's where it crosses the x-axis, right? Okay. So I'm going to go with, we did a good job so far. So I just want to write that down. The solutions, because you know we're going to have to graph these down the road. Not today, but we're going to have to. The solutions tell us where the graph will cross the x-axis. And another thing I want to tell you, yes, sir. Yeah, if it's an emergency, if not, wait till I'm done with notes. That solutions are also called roots or zeros. So sometimes they'll say find the roots or find the zeros. It means the same thing as find the solutions, okay? I don't want you to be like, what in the world, find the roots? What are they talking about? That's what it means, just find the solutions. Just a different word for it, different words. All right, so wasn't that exciting? I know. I'm ready to do another one. All right, let me label my paper. What is this, 7th period? Example 2. Now, that one seemed like it took forever because we were writing things down, I'm over-explaining, all that stuff, but it really doesn't take that long. So with this one, same directions, we are going to factor to solve 36x squared plus 60x plus 21 equals 0. 36x squared plus 60x plus 21 equals 0. If your head is down when we are working on our desks, do not ask me for help. It's not going to happen. Everybody's head needs to be up, paying attention, taking notes, asking questions when you don't understand. Remember we talked about, are you doing your best in class or no? Sleeping in class is definitely not doing our best. Okay, first things first. Is this set equal to 0 and in standard form? Is this set equal to 0 and in standard form? Yeah, okay, so I can skip that step. Next step is there a greatest common factor? Okay, well, if there is, we need to factor it out. What is it? Does 36 squared divide into all 3 terms evenly? No. Yeah, 0, no. Does 21 divide into 36 and 60 evenly? Something does. Okay, look at your smallest number. Yes. 21. What are the factors of 21? 3 and 7. 21 and 1, but that's not going to help us. 3 and 7. So if it's a common factor, it has to be, it can't be any factors that the smallest number doesn't have. So will 7 divide into all 3 terms evenly? 3 will. So 3 is a common factor, right? Okay. Or it could be 21. Will 21 divide into all 3 terms evenly? No. 3 will. So listen, kids still get confused on factoring out a GCF, so pay attention. We always put our GCF outside of parentheses. A lot of kids just pretend like it goes away. When you just pretend like it goes away, you've changed the meaning of the problem. It is one of the factors, okay? To figure out what is left after I factor out the GCF, I divide every term by the GCF. Yeah. So what's 36x squared divided by 3? Just 12? 12x squared. Think about it backwards. What's 3 times 12x squared? 36x squared, right? All right, what's positive 60x divided by positive 3? Positive 20x. If I distributed the 3 back in, 3 times 20x is 60x. That works out. What's positive 21 divided by positive 3? Positive 7. 3 times 7 is 21. 12 divided by 3 is 7. Okay. Sometimes when you factor out the GCF, what's inside parentheses may not be factorable. A lot of times it makes it linear. But we have a quadratic still inside the parentheses. So we're going to try to factor that quadratic. Not everything's factorable, okay? But if it is factorable, we got to factor it. So when I define A, B, and C, I am no longer factoring the original problem. Now I am factoring 12x squared plus 20x plus 7. So when you determine A, B, and C, don't look at the original anymore. Look at what's inside parentheses. So what is my value of A? Not the original. Look what's inside. Just the 12. What is B? And what is C? All right, so I've asked y'all to stop sleeping. That's not working. So I'll just make a note of who's sleeping, and I'll just include that on focus in the notes section, so that if there's any question why students don't understand something, I'm like, oh yeah, because they were sleeping that day. I don't know what else to do besides stop begging. Stopping begging. I'm gonna stop begging. Okay, so make your T-chart. I need two numbers on the left side, two numbers that multiply together to give you A times C. And on the right side, I want two numbers that add together to give you B. Okay, A times C, goodness, what is 12 times 7? Yeah, 84, and that's positive. And what is my value of B? 20. So the bigger the number gets, then the more factors it has. Sometimes it's a little more complicated to figure out what works. If you don't know, just pick up a calculator and start dividing, okay? So if you divide and the result is not a decimal, if it's an integer, that means it's also a factor. So I'm gonna say, okay, well, what's 84 divided by 2 is 42. That means 2 times 42 is 84. Well, hold on, just give me a second. Let me show you. Because a lot of times kids aren't really good with their multiplication tables. And if you're not, that's okay, but you're gonna have to do more work. So I'm gonna show you how to do it on the calculator to figure it out. Well, what's 2 plus 42? So that's not gonna work. Okay, let's see. What's 84 divided by 3 is 28. So that means 3 times 28 is 84. But what's 3 plus 28? 31. That's not going to work. All right, let's see. What's 84 divided by 4 is 21. That means 4 times 21 is 84. But 4 plus 21 is 25. We're getting closer, right? But I know it's not going to divide by 5. But when I divide by 5, I get 16.8. So that means that 5 is not a factor. If I get a decimal, it's not a factor. Pick again. Let's try 6. 84 divided by 6 is 14. Okay. So 6 times 14 is 84. What's 6 plus 14? Oh, we found it. Positive 6 and positive 14 is where it's at. Okay. So bring down the GCF. It does not go away. Just keep bringing it down. Make your two sets of parentheses like we did last time. The only thing different in this problem and the last problem is there was a greatest common factor. So the first term in each set of parentheses is whatever the variable being used in the problem. Usually it's X, but it could be M or K or Z or B, whatever. What variable are we using? X. So X is going to be the first term in each set of parentheses. Then you go to your T-chart and you look for the numbers that worked on both sides. Do not pick the 84 and the 20. That was the A times C and the B. That's a lot of kids make that mistake and they put 84 in one set and 20 in the other. What do I put? What numbers do I pick? 6 and 14. So put a plus 6 in one set and a plus 14 in the other. Now we have to do the old divide or slide. The A in the original problem is different than the A that we use in the T-chart. If you have a GCF, a lot of times the A is different. Always, always, always look at the A from the T-chart because that is the A value of what we're currently factoring. We changed the original problem, right? So the problem we're factoring is 12x squared plus 20x plus 7. That's an A value of 12. So I only tried to divide or slide the numbers that I took from the T-chart, not the GCF. So I'm going to try to divide or slide by 12. Not the GCF. 6/12. Can I divide 6 divided by 12 evenly? No, so that's going to be a slide. 14/12. Can I? No. What did I tell you happens when you have two slides? You have to reduce. Can't I reduce 6/12? Well, 12 goes into 6. 6 goes into 12, right, but that would be 12 over 6. Means 12 divided by 6. This is 6 divided by 12, which is 0.5 or 1/2. What? Reduce, yes. We have to reduce before we slide. I told you when you have two slides, that's when you're going to see reducing. If you didn't, and you slid the 12 over in front of x on both of them, if I were to check my problem, I'd have my first two terms would be 12x times 12x is 144x squared, when it should be 12x squared. That ain't going to be right. Okay, I can't believe it just said 8 on a recording. I haven't said 8 in years. Anywho, so let's make a note. You must reduce before you slide. If you don't, it's like you did the whole problem correctly, except if you don't do that, it's not going to be the right answer. So instead of 6/12, I'm going to reduce that to what? 1/2. So I have 3 times, open parentheses, x plus 1/2, close parentheses. 6 goes into 6 once, 6 goes into 12 2 times. So it reduces to 1/2. And then 14/12, what divides into 14 and 12 evenly? Besides 1. They're both even, right. So 2 always does. Is there a number larger than 2? 4 will not divide into 14 evenly. So 2. 2 divides into 14 7 times. 2 divides into 12 6 times. If you don't pick the greatest number to reduce by, then you're just going to see it can be reduced again. Okay. So now that we have reduced, now we can slide. So I'm going to slide the 2 over and put it in front of the x, and then the 6 over and put it in front of this x. So I've got 3, open parentheses. What am I going to write? Instead of x plus 1/2, I have 2x plus 1. Instead of x plus 7/6, 6x plus 7. Once I do the divide and slide part, I should be completely factored as long as I did it correctly. So I have factored, but have I solved? No. This has 3 factors. 3 is a factor, 2x plus 1 is a factor, 6x plus 7 is a factor. But am I going to get a solution from all 3 factors? I told you a quadratic can only have 2 solutions, right? But I have 3 factors. Well, when I set 3 equal to 0, does 3 equal 0? No. So 3, it is a factor, but it's not going to give us a solution, okay? So 3 does not equal 0. That's cool. It's just a factor. It will not help us with our solutions. The only place we'll get our solutions from is where we have variables, okay? So we'll set 2x plus 1 equal to 0. And we will set 6x plus 7 equal to 0. And then I'll just solve those both quietly. Y'all know how to do this on your own. You don't need me. So my solutions are -1/2 and also -7/6. You could call -7/6 -1 1/6 if you prefer. -7/6 is fine. If I were actually graphing this, I would definitely want to say -1 1/6 because that seems easier to find than -7/6 on my graph. Do y'all think you can do this on your own? Not right now? Need a few more examples? What part confuses you? You answered your own question? I like that. All right, example 3. Oh, I forgot to label on paper. What? What? This looks like more than a page? Well, I mean, I can use like 3/4 of a page. I'm kind of a paper waster. But my next page, I'm going to need more room than I have on this page. So see, I've already gone through 2 pages. I told you there was 5. We've only done 2 problems. This next page, I am going to fit 2 problems on. What? Yeah. Exactly. All right, example 3. We have m squared equals -6m plus 16. Whoa, 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 whoa. That one looks a little different. So in the very first example, we said set equal to 0 in standard form if not already. Is this one set equal to 0 in standard form? No. Most of y'all are going to want to subtract m squared from both sides. And I understand that because that's what's going to take the least amount of work. However, you don't want your leading term to be negative. Otherwise, you're going to have to factor that negative out, and it's just going to take you that much more work, okay? So if you move m squared over to the right, it's going to make your leading term negative. You don't want that. So bring the -6m over to the left and bring the 16 over to the left. And we can do that all in one step. It's NBD. Y'all know what that means? I made it up myself. No big deal. You can start using it with your friends. It's fine. So on the right side, -6m plus 6m is 0, and 16 minus 16 is 0. Okay, that's what we wanted. We wanted it set equal to 0. On the left side, I have 3 terms. I have an m squared, I have a 6m, and I have a -16. Are any of those like terms? No. If they are, combine them. If they're not, you can just rewrite every term by itself in standard form. So which term would come first? M squared. And then what? Plus 6m. And then what? Minus 16. Okay, so now we're at the same starting place that we were on the first 2 problems. Set equal to 0 and in standard form. So the next thing we do, we say, is there a greatest common factor, a GCF? Is there? What? Does 2 go into m squared evenly? Okay, no, it's got to go into all 3 terms. Is there a GCF? No. All right, so what is A? 1, what is B? And what is C? All right, so in yellow T-chart, we want 2 numbers that multiply together to give us A times C. And in this case, A times C is -16. And we want them to add together to give us B, which is a +6. Any ideas? 2 numbers that multiply together to get -16 and add to get +6. -2 and +8, okay? -2 times +8 is -16. And -2 plus 8 is 6. That works. So I make my 2 sets of parentheses. There's no GCF to worry about, so there's no number on the outside. What variable are we using this time? So m's the first term in each set. And then I'll look at my t-chart. Whatever the numbers were that worked on both sides is what I put into my parentheses. So I'll put a -2 in one set of parentheses and a +8 in the other. Now, what am I going to be dividing and sliding by this time? 1. So does -2 divide by 1 evenly? Yeah. Does 8 divide by 1 evenly? When you divide by 1, does it change anything? No. So really, when your A is a 1, you don't have to divide and slide because nothing is going to change. If A is any number other than 1 and you don't divide and slide, it's not going to be the right answer. Okay? So we have factored completely, but we're supposed to use factoring to help us solve. So now what? Set each factor equal to 0. Solve for the variable. Now, a lot of students will make the mistake and they will say that your solutions are -2 and +8. Is that correct? And no, because when you set equal to 0, that sign is going to change when you move it to the other side, right? So your solutions are +2 and -8. And what do these solutions tell us about our graph? They're the x-intercepts, right? Let me see. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And I know my y-intercept is at -16. So I'm going to guess the vertex is kind of like about, you can't see that. About, you can't see that. Scoot up. Just like a quick sketch. I'm just guessing about the vertex. I know the y-intercept is -16 because it's always your c value. But -8 and +2 are the solutions, the roots, the zeros, and that tells us where the graph crosses the x-axis. Right on? Okay. How many more do we have left? 3 more. I told you there's 6. And then you have to do some on your own on the table, on your desk. Sample 4, let's speed it up. 2m squared equals -10 plus 12m. 2m squared equals -10 plus 12m. Is this in standard form and set equal to 0? And no. Do we want to subtract 2m squared from both sides? No, because our leading term would be negative. We don't want that. Very good. So we're going to add 10 to both sides, and I'm just going to do this all in one step. You could do it in 2 separate. That's fine. And I'm going to subtract 12m from both sides. So on the right side, -10 plus 10 is 0. 12m minus 12m, 0. All we have left on the right side is 0. On the left side, do I have any like terms? I have a 2m squared and a 10 and a -12m. Any like terms? No. So do I write 2m squared plus 10 minus 12m? No, but a lot of y'all are going to because that's the order that you have it written, but that's not standard form. What term should I write first? 2m squared and then what? Minus 12m and then plus 10. Excellent. And then I ask myself, is there a greatest common factor? And there is, yes. What is it? 2. Can I take out an m as well or just a 2? Just a 2. So I put my GCF outside the giant parentheses. We haven't gotten to the 2 sets of parentheses yet. And to see what's left inside my giant parentheses, I divide each term by 2. And what is 2m squared divided by 2? M? No. M squared. You said m. Not m squared. Well, what's negative 12m divided by 2? I need a sign. Negative 6m. Signs are important. 10, positive 10 divided by 2. Positive 5. All right. So now when we define A, B, and C, do not look at the original problem. We are not factoring the original problem anymore. I took 2 out of the original problem. I'm looking inside the parentheses. So what is A? What is B? And what is C? So I need 2 numbers that multiply together to give me A times C. And what is A times C in this case? Positive 5. And on the right side, I want 2 numbers that add together to give me B, which is negative 6. Any ideas? Negative 1 times negative 5 is positive 5. And what's negative 1 plus negative 5? Okay, so that works. Everybody cool with the T-chart? So go back to your problem, bring down your GCF, make 2 sets of parentheses. What variable are we using now? M, so that's the first term of each set. And my numbers from the T-chart, put a -1 in one set of parentheses, a -5 in the other. Yeah. The 2 numbers that worked on both sides were the -1 and the -5. Don't put 5 and -6. That's what we were trying to find numbers to give us. What will we be dividing and sliding by? Is that necessary? Look at the A from your T-chart. Is it necessary to divide by 1? Could you if you wanted to? Is it going to change anything? No. So I have 3 factors. How many solutions or roots or zeros am I going to have? Just 2, because is that GCF going to give me a root? No, because 2 can't equal 0. Now, if that GCF would have been M, and you set M equal to 0, M can equal 0. That would be a solution. So you have to have a variable in the factor to get a solution from it. Okay, if it's just a number, you're not going to get a solution. 2 is a factor, it's not a solution. So I'll set M minus 1 equal to 0, and M minus 5 equal to 0. So what are my zeros, my roots, my solutions? 1 and 5. There we go. 2 more examples. So exciting. Any other question on that one? Okay. You want to take a test over this stuff? Or you like piecewise functions better? You do like piecewise functions? I do too. The word problem I thought was easy. That was pretty easy. Yeah. All right, example 5. We have b squared minus 49 equals 0. What is that nonsense? There's only 2 terms. Okay, well, do we have a quadratic term? We don't? A quadratic term means the highest degree is 2 of that term. We do, b squared is quadratic, right? So as long as we have the highest degree is 2, then it's considered a quadratic. You don't have to have a linear term or a constant, but to be a quadratic, you have to have the highest degree has to be 2. Then it's not a quadratic. We do it a different way, okay? So there is a shortcut to this because this is something special, but if you don't remember it, we can still do T-chart divide and slide, so we're going to do that first, okay? So is there a greatest common factor? No. What is A? What is B? 0. There's no linear term. C is always the constant. The constant's the number without a variable. Yeah. Because ax squared plus bx plus c is the standard form. A is the coefficient of x squared, so A is 1. bx. B is the coefficient of your linear term. There's not a linear term. There's no term with just the b in it, right? So there's not a linear term. We wouldn't say plus 0x. That's just 0. The constant is the number that doesn't have a variable. Okay? We could also have a b term and no c term. All right, so we want two numbers that multiply together to get a times c, which in this case, a times c is negative 49. And we want two numbers that add to give us b. In this case, that is 0. Any ideas? What could, just don't worry about it being negative 40. Don't worry about both sides right now. What could you multiply together to get 49? 7 times 7 is 49, right? But what's 7 plus 7? 14. Okay, well, we needed it to be negative 49. So what if I did like negative 7 times positive 7? That's negative 49, right? And what's negative 7 plus 7? Boom. So I make my two sets of parentheses. This time we're using a B. Make sure it looks like a B and not a 6. It's hard to do. Probably shouldn't use B's in algebra. And so from the T-chart, we're going to put a minus 7 in one set and a positive 7 in the other. Do I need to divide and slide? No, because A is a 1. So my factors are B minus 7 times B plus 7. What are my solutions going to be? Positive 7 and negative 7, because I'll add 7 here. So B is 7, I'll subtract 7 here. B is negative 7. So this is a special case. Notice your factors are identical except for one has the plus 7 and one has the minus 7, right? Everything else is exactly the same. When that happens, that's because the original problem was what we call, does anybody remember, you've learned this in Algebra 1, when you have a perfect square minus a perfect square, what is that called? No. The square root? Is that what you said? It's called a difference of, anybody know? Squares. Difference of squares, or some people say difference of two squares. When you have a perfect square minus a perfect square, it's a special case. We can factor it without even doing a T-chart. Y'all want to know how? We know. It's easy. You make two sets of parentheses. Can we do that? You put a plus in the middle of one and a minus in the middle of the other. Can we do that? Okay. The first term in each set of parentheses is the square root of the first term. What's the square root of b squared? Square root of b squared. Square root of b squared. What do you multiply by itself to give you b squared? What's b times b? B squared. So the square root of b squared is b. That's the first term in each set of parentheses. The second term, what's the square root of 49? 7, because 7 times 7 gives us 49. Notice the second two terms were both 7s. You can't take the square root of a negative. Okay, so when you think, just think about the 49 itself. Don't worry about the negative. So the square root of 49 is positive 7 and negative 7, because negative 7 times negative 7 is positive 49, and positive 7 times positive 7 is 49. But you said what's the square root of negative 49? That's imaginary. It's imaginary solution. We learned about that this year. I haven't learned about it yet. All right, so let me look at example 6. I have 4x squared minus 36 equals 0. 4x squared minus 36 equals 0. Is 4x squared a perfect square? Yeah, because 2x times 2x is 4x squared, right? Is 36 a perfect square? Yeah, because 6 minus it, or 6 times 6 is 36. Is there a minus sign? So this is the difference of squares. But before we do that, did y'all notice it has a G GCF. Don't we always take care of that first? Oh man. So what is the GCF? Not 4 squared, just 4. So I'm going to factor out a 4 from both terms. What is 4x squared divided by 4? X squared. What's negative 36 divided by 4? Negative 9. Oh, wait a minute. X squared is a perfect square. Is 9 a perfect square? And there's a minus sign? Well, what's inside parentheses is also a difference of squares. Okay, great. So we can do a shortcut. You can still do 2 chart divide and slide if you want. Shortcut. Don't forget your GCF. That's not part of the shortcut. You just got to bring it down. Here's the shortcut for difference of squares. Make 2 sets of parentheses. One gets a plus in the middle, the other gets a minus. It does not matter which one's plus, which one's minus. The first term of each set is the square root of the first term. What's the square root of x squared? X, because x times x is x squared. The second term in each set of parentheses is the square root of 9. Don't worry about the sign, just worry about the 9. What's the square root of 9? 3. Factored. Okay. What are my solutions? 3 and negative 3. The 4 is not going to give me a solution. When I set x plus 3 equal to 0 and subtract 3 from both sides, I get negative 3. When I set x minus 3 equal to 0 and add 3 to both sides, I get positive 3. Questions on that? This next example, we're going to work with markers on our desk, not markers, dry erase markers. I told y'all to get dry erase markers at the beginning of the year. Did anybody do it? A couple of you? Sweet, get them out. Everybody else, I'll let you borrow one, but I've got to sanitize it when you give it back to me. That's why I wanted everybody to have their own, because that's like 26 cents. Everybody's working on the problem. equals 2 and x equals 7. How many people got that? Okay. So first thing we have to do is get it in standard form and set equal to 0, right? So how am I going to start this? Subtract 9x from both sides. Everybody did that, right? So on the right side we have 0. What's on the left side? Very good. X squared minus 9x plus 14. Questions about that? Is there a greatest common factor? What is A? What is B? And what is C? Okay. Make our little T-chart. I need two numbers that multiply together to give me A times C, which A times C is positive 14, and two numbers that add together to give me B, which is negative 9. Yes. Okay. Negative 2 times negative 7 is positive 14. Negative 2 plus negative 7 is negative 9. Excellent. So I make my two sets of parentheses. X was the term, or X is the variable that we're using in the problem, right? Look at the numbers come from the T-chart. Put a minus 2 in one set and a minus 7 in the other. Do we need to divide and slide on this one? No, because A is some number other than 1. Okay, so I've factored completely, but have I solved? And no. So I set each factor equal to 0, and I solve for x. So on this one, when I add 2 to both sides, I get x equals positive 2. And over here, when I add 7, I get positive 7. And again, that tells me where my parabola would cross the x-axis. Am I right? All right, let's do one more, and then we'll call it a day. Any questions about this one? Okay. So we have a squared plus 40 equals negative 13a. A squared plus 40 equals negative 13a. I'm not finished. It's only 1:43. There's 17 minutes left in this day. All right, so I'm going to add 13a because we want it set equal to 0. So negative 13a plus 13a is 0. On the left side, tell me what to write in order for standard form. All right. Do we have a GCF? Okie dokie. What is A? What is B? What is C? So we're going to want two numbers that multiply together to give us A times C, which A times C is positive 40, right? And two numbers that add to give us B, which is positive 13. All right, 8 times 5 is 40. 8 plus 5 is 13. So I make my two sets of parentheses. The variable that I'm using is A. My numbers come from my T-chart. I have a positive 8 and a positive 5. Do I need to divide and sign? No, because A is 1. If it was any number other than 1, we would. So my factors, set each factor equals 0. So here I'll subtract 8 from both sides. So A is negative 8. Here I'll subtract 5. So A is negative 5. I told y'all not to pack up, and here I'm hearing zippers and whatnot. Y'all want to work? All right. Do you have any questions on that? Are you sure? All right. Next class, we will do some more review, and you will have an assignment. Okay. If you owe me, yes, I do. I'll send them. You're welcome.